Good morning, everyone. Not quite 10 o'clock. We will get started here in a minute or so on electrification and energy management systems. And I think, Michele, when I sent out the advertising for this, I put a link to your the 2-day one that you'd given for us. And I know a few people clicked and went to watch that. So I think some people are coming in with, some good base level energy management system knowledge at least.
Yeah, great.
All right, and as people roll in here, we will get started. You guys, I tried to go to a quiet room because it's been kind of noisy in my workplace the past couple webinars, but then the Wi-Fi cut out. So I'm here in my noisy office. And I am Katie. If you have not taken a Lighting Design Lab webinar, we're going to go through some housekeeping here on the next slide if you want to advance that for me, Michele.
Sure.
There we go. You guys are all going to be on mute for the whole time, but we do have a way to submit questions. Michele's kind of broken her presentation up into 4 different segments, sort of. So we'll kind of jump in between those segments and ask some questions. There's a little question bubble or maybe a little menu item that says questions. You can type your questions into. If you can't see the menu, look for that red arrow somewhere on your, if you have multiple screens, on one of the screens, and click that and the menu bar will slide out. This is being recorded and we'll post it about a week or so after we're done here. And there's a little survey at the end if you want to help us improve our offerings, that would be great. And then on the next slide, we'll show you a couple of webinars that we've got coming up. If you are a City Light, if you serve City Light with your, if you're a contractor or energy efficiency provider, man, it's not that early, but it is gray here in Seattle. It's affecting my brain. We're going to give you some updates next Thursday on some incentives. We've got 2 new ones that are pretty exciting that you might want to come learn about. And then at the end of the month, Eric Strandberg, who you know and love if you've been around Lighting Design Lab for a while, is going to give his lighting retrofits and audits class. And then in December, we are going to have some King County folks come and talk to us about CPACER financing and how that can work for your electrification and greenhouse gas reduction projects. Excuse me. I'm going to stop talking now. And Michele Sagehorn from Redcar Analytics is going to teach us about building management systems and how they relate to electrification. Thanks, everyone.
All right, good morning, everyone. I'm Michele, and like I said, I'll be teaching the class today. So maybe a little bit about myself. So I work for a company called Redcar Analytics, and we do a lot of different energy efficiency consulting. One of the services is commissioning, and that's kind of where my expertise is. I've been doing commissioning for about 15 years now, and I've had the opportunity to work on a lot of high performance buildings. I would say about a dozen zero net energy buildings and getting close to about 20 all electric buildings. So I'm pretty familiar with kind of those systems and how we kind of pull those projects together. And I also get to work on a lot of building automation systems. And if a project has an energy management system, I usually have some interaction there. So I kind of get to see a lot of the different flavors and manufacturers out there, as well as interact with a lot of the building engineers and maybe a sustainability manager to kind of see what they like, what they don't like. That's some really great information and feedback to kind of get. So hopefully I can share that with you today, as well as kind of share with you my experience of what I'm seeing there out in the field. Like I said, we do have this broken into 4 sections, and I'll kind of pause after each one for maybe about a minute and see if anybody has any questions. These are our learning objectives today. And so the first one there, understanding energy management systems. Many of you may be already familiar with them, maybe even use them on a regular basis. But I do think it's worth spending a little bit of time in this area just to kind of identify some of those nuances and things that are occurring, like I said, out in the field and that we're seeing. And then we'll move on to kind of some energy efficiency strategies and how an EMS can help kind of bring those to reality. And then section 3 there is our zero emission buildings and understanding how it relates to energy management systems as well. And the final one, which is one of my favorites, is just kind of those case studies. So I'm going to share with you some projects that I worked on personally and kind of those lessons learned and things, best practices and good takeaways from those projects. So, all right, go ahead and dive into that first section. Okay, so the definition of an energy management system is a software platform to use to monitor, control, and optimize energy use. Pretty easy definition, but I think the point that I'd like to make here is that if you notice, there's 3 things there: monitor, control, and optimize. And it's important to have all 3 to be a really good energy management system. There's definitely a lot of nuances out there today. Like I said, a lot of different softwares, manufacturers. And take monitoring, for example. I mean, I see a lot of clients out there that monitor things, but I would almost argue that's more of a dashboard than an energy management system because we're not necessarily controlling or optimizing energy. Another question that I get asked often is analytics software. That's a big buzzword out in the HVAC industry right now. And they'll ask me, is an analytics software an energy management system? So an analytics software can kind of analyze any kind of data from like the turnstiles at a security gate or how many times a conference room is being used a day or a month. So at the end of the day, like I said, it can analyze anything, but if it is focused on energy and optimization of like your building or HVAC or lighting system, then I would agree that it does qualify as an energy management system. But it's those little nuances, and there's a lot of acronyms used in the industry as well, and sometimes even the most technical people use them incorrectly. So kind of understanding those nuances, in my opinion, is really important, especially when we're dealing and talking with clients. All right, so obviously our EMSs have evolved, probably starting off by just using utility bills and then maybe moving to benchmarking, where maybe we were measuring our data from our bills but putting it in Excel and being able to benchmark the building. Obviously now we're in the age of computers where we're getting real-time data and we're getting lots of data. And so now there's, again, a lot of softwares and energy management systems to deal with large amounts of data and doing a lot of the analytics for us, trying to make things easier as we deal with a lot of complex buildings. So I wanted to start by sharing a couple EMS samples here. And so you're going to see 3 different ones here, state, campus, and building level. And one of the things you might notice is they all look very different. And that's pretty typical because at the end of the day, the energy management system should be kind of customized for that client. You know, they might have different uses for their building. They might maintain it differently. And of course, they may have different metrics or goals. So it is pretty typical to see things, pretty different between different clients. I went ahead and added the URLs down there. If any of you guys want to go check them out, I definitely encourage you to do so. I personally like kind of going and poking around and seeing what other people are doing. A lot of good ideas can be kind of copied and used, and so it's great to kind of take a look at that. The UC Davis one, which is the one right in the center there, is one of my favorites, I got to be honest. So I would say I definitely encourage you to take a look at that offline, and you're going to probably see me kind of highlight this one a couple times throughout the presentation. Okay. Another key thing to recognize is an EMS versus a BMS. Again, it may be obvious to some, but a lot of times for clients, they actually think they have an energy management system when it's just a building management system. And there are definitely some subtleties and differences. But the field is getting a little bit muddy because BMSs now can become EMSs. I have a couple projects, and I'm going to share a couple examples in our case study where we are building with the controls contractor a custom energy dashboard or pages within the building management system. There's also controls contractors out there that are starting to kind of have softwares that they overlay on top of the building management system that essentially, are EMSs, or make them EMSs. But the thing you might notice in there is that, an EMS is kind of, it's going to take the data that you get on a BMS, but it's going to use a lot of visualizations on how it presents the data. And it's going to help us a lot more than what you would typically see on a BMS. And so we'll get into that right now. And so when you have an energy management software, usually there's lots of different things you can do. I usually call them tools or visualizations. And so I wanted to just share 4 of them with you here today. Maybe I'll start with the energy use tracking down in the right-hand corner. This is probably the most common, and I would almost argue that it should exist on all energy management systems. It should be pretty standard. And essentially what you're looking at down there is the energy use. It's broken apart by end use. So you have HVAC, lighting, plug loads, domestic hot water, and then process. And you'll see several months of data there, about 3 months. And you have the ability to kind of make comparisons, like from this month to that, or from last year to this year. And, very easily can kind of take a look at high-level energy use and benchmarking, which is definitely something that I would encourage, is that we want as a building to know if we're, doing better, if we're getting worse, or maybe just staying the same. The next one to the left, load profile, is another one that I would consider to be highly recommended or standard for most energy management systems. So this load profile is looking at plug loads, but obviously it could be done on any load or your entire building. And it's really important to have this, especially as we move towards electrification, because we want to know when we're using energy. And we also want to know what our peak energy is. And so those are some key things to kind of know and have in the back pocket. What you're looking at here is a typical office building. So you typically will see that kind of bell curve, where we have our energy use during the day, and then at night it should go down close to zero, or definitely significantly lower. And where it becomes really powerful is when you start to overlay multiple days. So this is a 24-hour period, and with this chart is like overlaying 3 days worth of data. And by doing this, you really get to see your building again, you'll recognize patterns and anomalies and when things are different, maybe when there's a spike. And it becomes very obvious, but it's just a good way to kind of understand how your building is using energy. The next one right above it is a heat map. This is one of my favorites. And the reason it is because it's very easy to kind of understand. It's essentially 3 colors. It's red, green, and usually yellow or orange. And so the nice thing about a heat map is you can put a large amount of data on one chart, and again, visually can kind of understand it really quickly. So in this case, again, it's an office building. The red is symbolizing the use of energy, and the green is no energy, and so you would expect that during your unoccupied hours or non-business hours. And when you look at this graph, it doesn't take you but a couple seconds to realize there was probably a week there that there was energy use all 24 hours, running 24/7. So clearly something was going on. So it's easy to identify there's a problem, maybe something that needs to go be looked into or investigate further. And the last one on the right there that says cost, this one probably doesn't do a great job of explaining what it's doing here. But a lot of these analytics packages will kind of identify when you're wasting energy or when you're not being efficient. But it'll also do something where it will kind of give you a rough order of magnitude of how much that costs you. So, it will say something to the effect of, if you don't fix this, over a year's time, you're going to spend this amount of money. And this is really important too, because if we have a building or even a campus and we have a lot of different things we need to fix or address, you might want to know which one's the best bang for the buck. Or if you're trying to put together a project, an energy efficiency project, and you need to have that data to be able to get that payback, to maybe get that approval from, potentially management or whoever, having that kind of data is also very effective. So these are just a couple tools. Like I said, a lot of these softwares have a lot. Some are useful, some are not. I would argue that these 4 are pretty useful and like to see them in most of the energy management systems. Okay, so let's talk about briefly what makes an energy management system effective. Just because we have one doesn't necessarily mean it's going to work or it's going to, give you everything that you want. It really needs a little bit of care and a little bit of thought. And the two things it absolutely needs is to understand who's going to be using it. Is it a sustainability manager? Is it a facility staff? Or maybe even might be used for, sharing information with the building users or occupants. And then, of course, we have to have metrics. We have to have metrics that are specific to the client so that it's important to them. And so let's just dive into this just a little bit deeper. So when we talk about metrics or KPIs, key performance indicators, it's really important that they have all three of these things that's shown on this chart. It needs to be important to the client. If it's not important to the client, they're not going to probably spend much energy or time on it. But the other thing about this category is that when it comes to specifically to energy use, there's definitely sophisticated clients, but there's a lot of clients that probably don't know what their energy targets should be. So they are going to look to either probably a consultant or your design team for help in establishing these metrics. Now, the next one there is measurable, which seems like an obvious one. I'm actually from California, so what I see a lot is, for example, an engineer defining an energy metric, and they might say, okay, this building is going to be 10% better than the California Title 24 Energy Code. And that's based on a model that's run for code compliance. So it's very specific to the building, and it's not a real number. It's not like an EUI, an energy use index number. So it's not really a real measurable metric. So we don't have a number to kind of verify to. It's probably one of the reasons I actually really enjoy working on Z&E projects, because the energy goal is very clear. We want to be net zero over a rolling 12-month period. That's a goal that's very clear, that can be understood by contractors, commissioning agents, occupants in the building. So we're really trying to drive to that clarity in the metrics. And then the last one there being actionable. Again, seems kind of straightforward, but this is, again, once we define what the metric is or what we want, we also need to have that target value. Some cases it might be a range. Essentially what we're trying to establish here is when is something good and when is something bad. And what I mean by bad, it means there's something wrong here, we need to go take action. And so we have to be able to create, again, either a target or a range so that we know when things need to be actionable. Okay, so let's talk a little bit about the sustainability and energy manager. So as we talk about these different users, a sustainability manager is most likely going to look at things at a high level. So what you're seeing on the screen here is an energy management system, and it's a campus, or it's several buildings, I should say, a portfolio of buildings. And so it's kind of just giving you that high level of how each building is doing, and then a lot of just key metrics like cost savings, and then you see something like the top 3 comfort issues, top 3 energy issues. Again, very high level. A lot of times they're looking to kind of report to either upper management or being able to evaluate their high level sustainability goals for the company. And that's obviously going to be very different from, let's say, facilities personnel. They often are very, very busy. They're dealing with hot and cold calls, maybe doing maintenance. And, the ideal situation here is to make their life easier, to be able to troubleshoot and identify things that need to be fixed in an easy way. What you're looking on this screen at is an actual BMS. So it's not an energy management system, but it's using a heat map. And I find that a lot of building engineers like this graphic because, again, it's easy to understand. You're probably looking at either the whole building or maybe one floor of the building. And you can easily see the spaces in green are the ones that are within their temperature band. The yellow and orange are kind of borderline, and the red, of course, is one where it's out of bounds or either hot or cold. And something like this is an easy snapshot to look at and just kind of see how your building's doing. So it would be something that would be more geared to a facilities personnel. And then last but not least is our building users or occupants. They're often not really included in the energy management systems, but I definitely have seen it done, and I do think it is kind of a best practice, an ideal thing to do, because as we again move towards either electrification or zero net energy buildings, I can tell you in my experience when I work on them, a lot of times the occupants will come to me and they'll be like, how do I help? Or what are things I shouldn't do? You know, if there's operable windows, they'll be like, hey, should I open or keep the window closed? Because they want to help the project or the building reach the goal of Z&E, but they don't really understand how their behavior impacts it. So being able to provide them that kind of information can be extremely helpful, because they actually do play the largest roles in how buildings use energy. Okay, so why is this important? Well, unfortunately, a lot of buildings don't work, or they don't live up to their energy performance metric. And there's a lot of reasons for that. I mean, starting in the design phase, again, you might have an energy model that is based more on code compliance than it is on building energy performance. And then as you move through construction and commissioning, there's a lot of things that can go wrong, and there's the VE process and a lot of other things. And as we move into the operation phase, you know, we could have a building being used in a different way than it originally was designed, or those original design assumptions. And the one that I'm hearing more and more often is building operators saying, hey, this building is very complex. I'm not really sure how it's supposed to work, or when I'm supposed to do something, or when something needs to be adjusted. And the reality is again, as we're moving towards more efficient buildings, it unfortunately makes buildings more complex. And that is a problem. And I would argue that one of the problems we don't have is data. You know, nowadays we are getting massive amounts of data. We're measuring everything and can get hundreds and hundreds of data points. But that also can be problematic too, right? Too much data can kind of help make us lose focus or not really focus on the right things. And it can be very overwhelming. And that's really where energy management systems come in, is they can help us kind of maintain the building, verify its performance. And if we do eventually get it to the metric, hopefully that we, you know, want it to be at, we want to be able to maintain it, not just in that first year, but year over year, you know, persistence energy savings. And the reality is as these buildings get more and more complex, we need tools and things to help us do that and make that more efficient. So I'm going to pause there. That's kind of our first section, guys, as far as kind of a, you know, brief overview of energy management systems and kind of, you know, again, how to make them effective, and so those little nuances that are needed. But if anybody has any questions, I'm going to just kind of pause here for a minute.
We don't have any questions right now, but feel free as you think of them, you guys just put them in the questions bar and we will get them answered.
Okay. Okay, all righty. So I'm going to go ahead and move right into section number 2 here, which is kind of energy efficiency strategies. So what I would say is, you know, this presentation is trying to kind of be geared or focused on electrification. But at the end of the day, energy management systems, as we all know, have been around for a long time. So probably many of the things I'm going to share with you are not only applicable to they're basically applicable to all buildings, not just electrified ones or all electric ones. But there are some things and key things to kind of point out. So I'm going to try to do that as we go through this. But as we move into this energy efficiency strategy, which in all honesty, a lot of the strategies are not all that different from a non-electric building, I wanted to talk about some of the energy management attributes by using some real world examples and how this is important and how to make, again, the best use out of your energy management system. So the 4 that I'm going to talk about are customization, data tagging, navigation, and visualization. And there's probably more out there. I just think these 4 are kind of my top 4 anyway, so I wanted to kind of share that with you. So moving into customization, it is basically what you would expect. You know, the ability to be able to customize your energy management system. And again, that goes back to each client being a little bit different, having different goals, and it can even mean just putting, you know, your own logo or colors on it. But at the end of the day, it becomes actually quite important when we talk about electrified buildings, because there's a lot of standards out there for analytics for a typical building, but not necessarily for ones that are kind of using the technology that's going into these all electric buildings. And so I'll explain that a little bit more, but let me just kind of show you with an example here. So the example I'm sharing is a fault detection diagnostics, which is another buzzword that's kind of going around the industry, automated fault detection diagnostics. And really what it is it's an analytic tool. We're basically doing some analysis on some data points and making a decision of whether something needs to be done or not. So on this particular example, it is for an air handler VAV system. So let me just kind of walk you through this first one. You'll see the description at the bottom says AHU MAT low. So that is the air handler mixed air temperature low. And what it's trying to do is looking at that mixed air temperature and it's comparing it to the outside air and the return air. And it's saying, hey, it should be between those two temperature sensors. If it's not, then there's a problem. And so there's a little, in this case, it's a pretty simple equation, but there's an equation to kind of analyze those three data points. And then obviously, if it's not within those two, the outside air and the return air, it's going to alert you. But there's a very big distinction here because it's important that this is not just another alarm. You know, I'm sure most building engineers would tell you that's the last thing they want is more alarms and definitely no nuisance alarms. So the big distinction is that it will give you, when it's outside of those bounds, it's going to give you a possible diagnostics and also a recommended action. So a lot more information than you would if you got an alarm. And so in this particular case, the recommended action is to go look at the trend data for the last week for those three data points and see if you see anything that seems, you know, out of the norm. You might see a spike, or, you know, a lot of times when sensors go bad, they'll go to a crazy value like 200, or maybe it'll be just 0. But essentially, you might be able to identify which sensor's bad quickly by just looking at those trends before you would even go out into the field to do any investigation. And then obviously the possible diagnosis is most likely it's a sensor bad. So at least it's giving you some information of possible things, most likely things to occur to kind of start with from a troubleshooting perspective. And that is, again, something that's pretty important. So for California anyways, package units are required to come with fault detection diagnostics built into it now under our new code. But there's also ASHRAE Guideline 36 out there that has a lot of fault detection diagnostics kind of standardized. It's changing, but I would say at least up until recently, it was mostly, again, just a typical air handler VAV air-based kind of system. So there wasn't any fault detection diagnostics for like a heat pump or a VRF system per se. And so that's where this customization comes into play, is if we have an energy management system, we have the ability to customize some of these things so that I'm sure the industry will eventually catch up and hopefully we'll have these fault detection diagnostics for other systems. But at the moment, I would say a lot of them don't exist. And so it becomes important to be able to create something that's useful for your building. All right. Okay, so the next one is data tagging, which is probably what you're thinking. It's how you label data points, but it's a little bit more than that. So in this particular example, this is a real example from a client that I worked with. They have a campus. I would say there's about 30 buildings on the campus. And so the engineers, and I'll be honest, I'm not sure why they were evaluating this, but they wanted to do an evaluation of all the air handlers on campus, and they needed the supply air pressure from all these different buildings and air handling units. So they went out to find the data. Before they did any analysis, they just needed to find the data. And what they discovered was there was 19 different ways that that data point was labeled. So you can imagine it wasn't the most efficient use of their time. I'm not sure how long it took them, but they had to put some effort in just to get the right data and find it. Where if things were labeled in a standardized way, it would be very quick and easy to get that information. So that's the obvious thing about data tagging, and that's doing that is helpful in obviously in the construction commissioning phase, but also obviously in maintaining the building as well as doing analytics on it. So for example, when we look at that supply air pressure and we standardize it, there's more to this than just that. We can now add a whole bunch of data to that. Instead of it just being a temperature sensor or a supply pressure sensor, I now can add like a geolocation to it. So I know exactly which building it's in, what floor it's on, what room it's in, and what piece of equipment it is associated with or controls. And so that makes that way more powerful. And to kind of put that into context, in the same campus, the sustainability manager was looking into, he needed to replace some chillers. So he decided he wanted to go out and kind of search what was going on with the current chillers on campus. And so he was pulling data from chiller failures. And so now with this data tagging, you can associate information with it. For example, you can put the manufacturer, the make, the model, the year it was installed, things like that, that are important points. So he was able to kind of pull that, and he noticed that there was one manufacturer that was failing a lot more than others. So that was good information to have. I mean, I'm not sure what he landed up buying, but at the end of the day, he might want to kind of avoid that manufacturer. So in my mind, by doing this data tagging, we've kind of opened this into a whole new world of data analysis and how we look at data. I'm just typical looking at the supply temperature. Now I have a lot more information with it, or potentially, and you can kind of do a lot more analytics than you probably previously could. And so it's definitely more powerful and something that can be used in these energy management systems. All right, the next one there is visualization. And so again, there's my little UC Davis one. And so when you look at this, and this is really a big distinction between energy management systems and building management systems, is that it is presenting data in usually in a chart, a graph, or something like this, so that you can easily identify, again, things that are different, unique, anomalies, and it's not like looking at just a trend data, which is what you typically get on a building management system. So on that UC Davis one, what you're looking at there is all the little tiny dots are all the buildings on their campus. And the kind of shaded circles around them are the energy intensity. So obviously the larger the circle, the more energy the building uses. And if I was a sustainability manager, the campus manager, that might be a really easy way to kind of see all the buildings that are using the most energy. But it goes a bit further. If you hover over any one of these with your mouse, it'll give you some more information. Like it'll say, let's say we go to one of those larger circles, it might say this is a lab. And so it'll identify the building type, and it'll have a little information there like, hey, labs tend to use more energy than a typical office or a library or something like that. Here's the reason why. It additionally gives you the actual EUI of the building, so you know the actual energy intensity, and it also gives you a comparison to the benchmark for all buildings of that type. So we would be comparing only to labs and be able to kind of see if that particular lab is above or below the benchmark in the industry. So that gives us a better idea, because it's not fair to compare a lab to an office. But if I'm above the benchmark by a lot, I might recognize that there is a lot or potential energy efficiency measures that could be kind of implemented in that building. And so to me, this is just a really great use of visualization. And again, that's where the real power of energy management systems come into play. Now, the last one on my list was navigation, and I don't have a slide for it, but I'll just kind of use the same example here. So when you're on this EMS at UC Davis and you click on, again, one of those buildings, and let's say you want to find out more information about it, you just kind of click it and takes you to the building, and then it'll take you deeper and deeper and deeper into things. And that's what I mean by navigation, is getting to the information as quickly as possible. That's a great feature to have. It's not always easy to identify that in different software packages or different energy management systems out there, but it is something to be aware of. It is something that on some systems you can customize a bit if you know how you want it to kind of flow. Okay, so let's get into an energy efficiency strategy that you guys all may be familiar with. So supply air reset on an air handling unit. So this is a BMS, typical air handler, and resetting the supply air temperature as an energy efficiency measure is not a new strategy. But I will say that when I originally started doing commissioning, let's say about 15 years ago, it typically was done by looking at the outside air temperature. So when it was hot outside, we would drive the supply air temperature down to the bottom of its reset, like maybe 55 degrees. And then if it was cold outside, we would let the supply air temperature rise up to the high end of the range. That might be 65. And it was very simple, easy to implement, and generally, would work and definitely saved energy. But as we're moving to trying to squeak out every little bit of efficiency we can, the newer kind of control strategy is kind of this trim and response, which is essentially looking at the building itself, saying, what is happening in my building? Forget about what's going on outside. What does my building actually need? So, I mean, it could be that the building's completely empty, and so it really doesn't need much. So it's going to look at the different zones, and the zones will send a request. So typically they'll send a cooling request. And so if you can kind of see the circle there, I've circled a couple things. And you'll notice that there's currently 2 supply air requests. And that's how many zones would be calling for cooling. Now, the other thing about looking at it from the zone level is you anticipate, again, that on paper this looks great. I should be able to save more energy than that whole outside air reset. But if it's not implemented properly, you can actually do the opposite and not only not save energy, but maybe waste energy. And so that's where this becomes very important. Because the reality is it becomes more complex. We have a lot more variables and programming that goes into making this work properly. And so you'll notice right below it, the supply air request, there's another one there called ignored request. And right now it says 1. And so basically, as long as you have more requests than you have ignored, it'll start to drive your supply air temperature down to the bottom of the reset. And it'll do that like over every 10 minutes or 15 minutes. It might drop the supply air temperature by like, let's say, 1/2 degree or 1/4 degree. And eventually, if the request can stay there, it'll keep it at that level until the requests go away. So one of the things to note is that ignored requests is often, I would say, a lot of times it's not even on the graphic screen for people to be aware of. It might be buried in the programming code. And it really needs to be accessible, not only for the building engineer to understand what's going on, but also in case it needs to be changed. Because typically the engineer, or the way it normally gets set up, is that it would be either 0 requests or maybe 1. And so when this occurs, and this is something that I have seen too many times out in the field, is that you might have one zone that drives your whole building or your whole supply air temperature reset. And so I can't tell you how many times I've gone into a building and that supply air reset is literally just sitting at 55 degrees all the time. And that's because one zone is driving the building, and because of these parameters that go into the programming logic. And there's a lot of reasons why that occurs. It could be because, I would say the typical one is because it's an IDF or MDF room, and you might actually have multiple on your building. You might have one on each floor, and those tend to always be calling for cooling. Another thing could be the VAV box is undersized, and there's probably a lot of other things that could cause it too. But at the end of the day, you could have one zone driving it. So how would I know that, or what would, how would you kind of investigate or troubleshoot that? Well, you could on your BMS look at a trend of the supply air temperature, and you would notice that it's always at 55. So that would, easily tell you there's a problem. But kind of trying to figure out which zone is driving that, or which one is, or it could be multiple zones, but which ones are kind of driving that, is not as easy on a BMS. It's doable, but it tends to sometimes take a lot of time. A lot of systems you have to actually kind of go through each zone and try to identify that, or trend all of them. Or you might be so lucky as you have kind of a summary page of all the zones, and maybe you can figure it out from there. But again, it can be a lot more time consuming, where if we had an energy management system and we had a visualization like our heat map again, you'll notice that in this example, it is basically every VAV box in that particular building. And so you can clearly see that there is one VAV box that is always in red, always calling for cooling or always needing more air, and easily identify which VAV that is. So this is where, again, the visualization, it makes everything a lot easier and helps you kind of verify that your building is actually working properly and using that energy efficiency measure. So if you found out this, you could go change your ignored request. You might not be able to fix this issue right away, but if you have the ability to go back to your building management system and make an adjustment, you can, kind of change that parameter. Okay. All right, so let's go ahead and move on to another one. So in this particular example, what I wanted to show you, this happens to be a package unit, and I think it's very relevant to, again, electrified buildings, because what I'm seeing is, we're going to see more different equipment, of course, all electric, but, heat pumps, VRF systems. And so what you're typically seeing now from the engineer or from the sequence of operation is that it'll just send it an enable and it'll send it a set point, and that's it. And then we let the manufacturer's controls do everything else. And so I call this like a black box. At the end of the day, we don't really know what's going on in there and if it's working right or what it's doing. And, that's maybe not ideal. But one of the positive things about this is that nowadays we are integrating a lot with a lot of these systems, so we can connect to it. And a lot of the manufacturers are providing tons of data that can be brought into the BMS or your energy management system, and then we can analyze it and utilize it to kind of verify performance. So, you might be able to see, like, let's say there was 2 compressors. You can see when each compressor's on, or when, which one fails, and then a lot of times there's a ton of different information. But one of the other key pieces that not all, but a lot of manufacturers are doing is providing you KW or KWH data on that unique piece of equipment. So that's where that becomes very helpful, because now instead of just looking at our HVAC as this big pie, we can start to see individual pieces of equipment and how much energy they're using. Similarly on a VFD, which could go on a pump or a fan, we can pull the KW from that VFD and really start to break down our HVAC system into a lot finer detail. We also then have the ability, if we're able to get that data, to create additional metrics, like, for example, CFM per watt, which is essentially the efficiency of that piece of equipment. And we might be able to, if we want to set a range around it, we could do that, or just kind of confirm it to the design intent. But ultimately, it does give us the ability to kind of create our own custom metrics. So there is, like I said, some positives and negatives to this, but definitely that is a trend where I'm seeing on most buildings is bringing a lot of that information and trying to use it in a way that's helpful. Okay. So in California, our Title 24 requires us to segregate the electrical loads at the panels. And so we separate them by end use, which is great, but it doesn't require us to put submeters on. But what I would argue is that once you've segregated them on the electrical system, it's very easy to add submeters. So this is definitely a trend that we're seeing, is that we have a lot of submeters, a lot of data that can help us kind of put it in perspective, like that pie chart to the right, where we're looking at the electric use by end use. And I would argue this is a good visualization too, because now, if you go back to your load profile on when I use data, or excuse me, when I use my electricity, now I can tell where I use it. What is using the most? In this case, we can see that the pie chart very easily is the space heating. And again, that might be an area that we want to focus on or has the most energy efficiency potential. So again, having these visualizations make it a lot easier to understand and gives us a higher degree of analytics. So, and this comes into play a lot in zero net energy buildings, and I'm going to show you that in one of the case studies. So, kind of keeping with this submeter, so this is an actual project that I'm working on, and this is a graphic that is shown on a building management system. This particular client wanted to bring the electrical data into the BMS, and this was their first attempt. So they're kind of like, hey, here you go. And I'm like, well, first of all, that is just instantaneous data, right? And you can see there that it's not even saying what's on each panel, so we don't know which one's lighting, which one's plugs, or anything like that. But again, it's instantaneous. It's not showing us like a month's worth of data or a year's worth of data. It's not accumulating that for us and showing us that pie chart. So this isn't something that's very useful, But a lot of people do believe that if you bring your sub-meter data into the building management system, that automatically makes it an energy management system. That's just not the case. You know, it might be a step towards it, but you know, there needs to be a couple more steps. We need to do something with that data to visualize it and look at it in a different way. So here is an example of how you might want it to look. So this is, again, a real client of mine. They this is two separate buildings. In the building on the left, you'll notice that there's, you know, a lot of different colors that are stacked on top of each other. Those are all the different submeters by end use. And so that's all the submeters. So obviously all of the submeters should add up to the whole building meter. And the whole building meter is that black line at the top. So you'll notice that they're missing a lot. 66% of the load is missing. Not ideal. And again, as we use more and more data, we need to make sure the data is good. I mean, if we bring bad data into our energy management system, obviously we're probably not going to get very far. So it's very important that the data is accurate. The graph on the right obviously looks beautiful, and that's the way you would want it to look. Now, this particular building, they got it there, but I will tell you, there's, you know, it took them a little while. It also had a gap, not quite as big as the one on the left, but it did have some issues as well. And ultimately, they were able to get it to, you know, look, like I said, how it should look. But where I would say is that, you know, when you look at these charts, you can easily see there's a problem on the one on the left, and the one on the right looks good. But it's the way the data is displayed. Kind of going back to the chart that or the graphic screen that I just showed you, you can see that this is not very helpful, and, you know, not going to tell us if there's a problem. So it's something to keep in mind, that the way we display the data is extremely important. And again, this is what we see typically in an energy management system. One other thing that I would want to point out is that electrical meters are not required to be commissioned, at least not by our California Energy Code. If the client chooses to do LEED with the U.S. Green Building Council, if you guys are familiar with that certification, there's a credit that is an optional credit called monitoring-based commissioning. If they select that credit, they have to install an energy management system, a permanent one, in order to achieve that credit. But it doesn't really tell you, you know, what it should be and what kind of tools, or all the details are left out. So there's a lot of room for interpretation. But I guess where I'm going is that, believe it or not, a lot of meters have problems. I think a lot of people believe that they're kind of plug and play. But I guess where I'm going with this is, I would recommend, whether the client's going for LEED or not, that electrical meters and sub-meters become part of the commissioning process, and that they are actually verified that you're getting good data. So that is definitely a lesson learned, and something to be aware of. Of course, again, we need accurate data. Okay, so moving into one more energy efficiency strategy here is lighting and HVAC integration. So this is becoming, again, very popular. We actually, I think in the code cycle, the 2019 code cycle now, actually have to implement this on new construction projects. And so what we're doing is integrating the lighting and the HVAC. What we call it is occupied standby. And getting this to work is kind of going back to that supply air temperature reset. It should save energy, but if implemented incorrectly, can actually cause more harm than good. And so what I would say as a commissioning agent, because I deal with this all the time, is that the integration of these two systems has not been easy. It's often a challenge on pretty much almost every job. And part of the reason for it is these two systems are very different, and they historically have not talked to each other very nicely, let's just say. And some of it's about proprietary software and things of that nature. But they just aren't really speaking the same language. You know, when we talk about a lighting zone, that is very different from an HVAC zone. But in order to implement this, and I guess let me describe essentially what it is. So let's take a typical office. And most offices now, you know, most spaces within that type of building are going to require an occupancy sensor. So if and this occupied standby should only be occurring during occupied hours, not unoccupied hours. So let's say I leave my office and I go to a meeting for a couple hours. After the 15, 20 minutes, my occupancy sensor is going to time out and my light should go off. Well, now as we tie them to the HVAC system for an additional energy efficiency measure, what should additionally happen is that we will change our temperature band and it'll get wider. So if we had 70 plus or minus 2, it might be like 70 plus or minus 4. And then we will also shut off the air supply to that space as well. And so until somebody comes back and triggers that occupancy sensor again, and that during that period, we should be obviously saving energy. And as long as we stay within that temperature, the new temperature expanded range, it'll stay in that mode. But again, where the complexity comes in is kind of how to implement this. So the example that I'm showing you right here is if you had multiple VAVs in one lighting zone. So that kind of highlighted section is, let's say it's an open office, and there might be, I'm just going to say maybe 2 occupancy sensors in there. So those need to be tied together to create one lighting zone occupancy sensor. But then you have multiple VAVs, so that lighting zone occupancy sensor signal needs to go to every single one of those VAV boxes. So there's a mapping process that occurs here, and that's where this gets really challenging, is who's responsible and how to get that information and map it properly. Now, the flip side of it is the opposite. If we had multiple lighting zones in one VAV zone, so in this particular case, you can see the smaller, the greens and blues, those are like maybe small private offices, and then the yellow is kind of an open office. So those are all being served by one VAV, but obviously there's an occupancy sensor in each one of those private offices, and then probably 1 or 2 out in the open office. And so if any one of those occupancy sensors are triggered, we need to supply air and keep our temperature control. So even if there was only one person in one of the private offices but nowhere else, we still needed to do that. But again, there's a mapping and usually a little bit of programming that goes involved into implementing this particular energy efficiency strategy. And like I said, believe it or not, it's still quite challenging to do successfully. And so what I've seen is that sometimes when it's implemented incorrectly is that equipment is actually now coming on during unoccupied hours. So I've had a couple clients where, the sensors might be triggered by, let's say, the security guard, or potentially maybe the cleaning crew comes around, and all of a sudden your equipment's running for, a couple hours in the evening because they get tripped. That's one of the things that can go wrong. There's a couple other things as well. But when this all kind of came about, it made me start to think about lighting analytics, because I never really thought about lighting analytics. I was mostly HVAC equipment. And so this is a screenshot from an energy management system, and it is showing occupancy sensors. And at the bottom, those lines, ideally you would have, all of them or as many as you could on one page, but you can see the purple and the orange are on all the time. So definitely a problem there, but very easy to identify. And then the blue chart at the top is kind of your cumulative of all of your occupancy sensors in the building. So again, kind of falling in with that typical office schedule, you'll notice it goes up and then comes down. But even during the unoccupied periods, it looks like there's about 8 that are always triggered on. Maybe that's right, maybe it's not, but it's definitely giving you some good information there of what's going on. And so, yeah. Okay, so what is the problem here? In my opinion, again, this chart on the right is a typical BAS trend data. We can get all the data and we can trend it this way, and it's giving us information, but again, it's not very useful, or what I like to say, actionable. Are we good? Are we bad? Now, the chart on the left, or the visualization on the left, is actually an app from my phone. About 2 years ago, I installed solar and a battery system on my house, and this is an app from it. So now I can look at the high level data and really understand when I'm using energy and where am I getting it from, my own solar system, from my battery, or from the grid, and so on. So it's very nice high level data, and it's really easy to do comparisons. Like I can look at today versus yesterday, or this month versus the same month last year. So again, all of those easy, nice little things, but put it in a very pretty chart that's easy to understand. And by looking at this high level data, literally not even getting into the weeds, I have made changes on how I do things around my house. Like I have an electric vehicle, so when I charge it, I started to change how I charge my car now based on this data. And similarly, some of the things that I do around my house that are energy intensive, I've been able to shift when it seems more appropriate. So going back to what is the problem is that I have something like this for my house, but I see multi-million-dollar buildings that don't have something like this, which is kind of frustrating in my opinion. And I know this is maybe a little bit about how I feel personally, but I almost feel like this should be kind of standard on a new construction project. And why is it so challenging to get this information in a nice, easy, digestible way? So my hopes is that we're kind of moving towards this. I also had kind of high hopes that maybe all building automations would at least have a few visualizations like this that are very high level, because like I said, we are bringing in all of this electric data a lot of the times to the BMS. All right. So that's the end of that section. I'm gonna just pause again. Now,
Yep, we had a couple of questions. And the first one, I don't know that you'll be able to answer unless you're familiar with what the Seattle Energy Code is going to require for 2021. Are you familiar at all, Michelle?
well, I do know, I think I had seen that Seattle new construction actually required energy management systems to be installed on new construction. So I don't know if it has anything to do with that, but I am familiar with a little bit about that.
Yeah, so the question is, what characteristics does an energy management system need to meet the 2021 SEC requirements for quote unquote data acquisition system with actionable display and end use monitoring for HVAC, domestic hot water, etc.
Yeah, well, it's a good question, and I guess what I would say is I hope it does get defined a bit, because as I mentioned, LEED does not define it at all, which is, in my opinion, kind of problematic because you get all things under the sun. But what I do recall that I've seen a pamphlet, and again, this was probably a previous code cycle for Seattle, but there was a pamphlet regarding this kind of energy management system requirement, and it did list at least I want to say like 4 or 5 bullets of what should be included in that energy management system. It probably wasn't as detailed as whoever asked the question would like, or maybe we would want. So maybe in this next code cycle, it'll get a little bit better. But I will give you credit that you guys were defining at least some level to that. And if somebody's interested in that, or I'm sure I have it saved somewhere, so I could surely share that information that I have at least right now.
Great. And I know a handful of my Seattle, City of Seattle coworkers are on the call. So if anybody knows a good link or something, you can toss that in the chat and I'll send that out to you. And then the next question was just kind of a wondering about visuals on EMSs. They said that it seems like the benefit is to make it easier for human users to spot issues and trends, but wouldn't any issues or trends be automatically detected by the system? What am I missing here? They wondered.
Yes, so there definitely is with these analytics, built in kind of, again, equations and things that they're analyzing for, specifically efficiency. But what it'll do is it'll send you kind of an alert, or, you know, I'll use one of the manufacturers out there, SkySpark. It sends you a spark. So it'll tell you when something's not operating efficiently. So you're right, it's all automated. You don't necessarily have to go out there and look for this particularly, but then when it tells you that, it doesn't always know the root cause of the problem, right? And sometimes in some cases it could be multiple different things. So sometimes it's obvious and and you know how to fix it and address it, and sometimes it requires some further deeper investigation, and that's where kind of you might need to dig a little bit deeper, and that's kind of where those visualizations come into play when you have to kind of take it to the next level. Hopefully that's helpful.
Excellent. Yeah, that's kind of it's kind of annoying not having people ask because then you can't have the
Well,
have the
and then Yeah, and then once you do it, kind of identify, like, for example, as I mentioned, sparks. I mean, you might have 20 different sparks that day. So then you want to know which ones are occurring all the time, or which ones cost you the most amount of money. And those ones might be the ones you prioritize as far as fixing. So a lot of those softwares actually do that for you.
Excellent. Okay, that's all we've got so far, so we can continue on.
Okay. Okay. All right. So as I've been kind of discussing so far, a lot of these strategies are applicable to kind of really any building type. But I wanted to get a little bit specific about zero emission buildings. And so again, I don't necessarily, at least as a commissioning agent, see that many different energy efficiency strategies. But here are some of the things that I see that are different or unique when we talk about electrification approaches. Of course, most of those buildings are going to have some type of renewable energy, solar predominantly. One thing that I will note about solar is this is something that I typically deal with in the commissioning of a new construction project, is that a lot of times a solar system will come and they will have their own kind of link or their own little online dashboard or URL you can go to that you can see data or see how the system's doing. And so again, there's your production data, but then we might have our energy data or consumption data in another location. It could be on another dashboard or for the electrical meters, or it could be brought into the building management system, or again, the energy management system. But the thing that's important here, and again, as we move towards Z&E projects, is that you need to have production and consumption data in the same location so that you can analyze it and look to see if you're on track, specifically for Z&E. And so unfortunately, again, in a lot of new construction projects, if they don't have an energy management system, your production's in one location and your consumption's in another. And to me, that's very problematic, is that you need to have these two things, in the same location. Of course, we see a lot of energy storage, batteries and thermal storage. And again, this is another reason for having consumption, production, and your battery or your thermal storage information all in one location so that you can identify, kind of like I talked about my app for my home, when you want to pull pull energy from the grid or pull energy from your battery. So understanding that and having it in one central location is actually really important so that you can make choices and make decisions efficiently for your system. And then demand management controls. This isn't really anything new. I mean, again, this has been going on buildings that are not necessarily all electric, but what I have not been on a project where they've actually tied to the grid. So, as far as your shedding, I've had it where we've set up, there's basically a manual button that the facilities engineers can press, and that will put your HVAC system in, again, a wider temperature band, minus maybe your critical zones. And similarly, on the lighting side, you can put it into either turning the lights off or dimming them to a specific level. So I've seen those strategies implemented, but again, not one that has been automated or connected directly to the grid. But I think that's where it's going, and I'm going to show you an example in just a second here. And then, of course, we have, again, a lot of different kind of equipment, high efficiency, all electric equipment. So we're seeing a lot more heat pumps, VRFs, I would say a lot more black boxes. And then even kind of getting some clients to get into the all electric appliances. And then we have kind of permanent building load modifications that are really more architectural features to help kind of permanently remove, a cooling load or something like that. So those are some, probably not all, but some of the strategies that I'm seeing a lot of. And so let me go ahead and share with you this next example. So Sonoma Clean Power is a power provider here in California. It's actually right in my backyard in Santa Rosa, California. And this project, unfortunately, I didn't work on it. I had hopes to, but it is considered the world's first grid optimal building. So let me just tell you a little bit about it. So first of all, this was an existing building, so it was renovated. The original building was built in 1979. It's 15,000 square feet and obviously designed to be zero net energy. It's been occupied now for a little over a year, so they actually have some data on it. The EUI was designed or predicted to be 33 kBTUs per square foot a year, and they actually achieved 24, so they were much better than that. Some of the other features on the building were, of course, a highly efficient all-electric HVAC, a lot of use of skylights, windows, and daylighting. And they have 23 car chargers that they actually use as part of their battery system, and then a 220 kWh battery system, as well as solar, but I'm going to be honest, I'm not sure how large their solar system is. But anyways, a lot of great features. But let's talk about what makes this kind of a grid optimal building. So they are actually using some software called microgrid controller with watt time software to track the grid emissions. So if you guys recall, in the beginning when I showed you a couple examples of energy management systems, one of them was a link to the state. That was, well, it was happened to be the state of California, but if you go to that website, you can see what the grid is doing. You can see what it's producing and where it's getting its energy from, you know, whether it's a coal plant or whether it's, you know, getting most of its energy from solar or wind. And so you can kind of see how the grid is and when the peak times are, all that kind of information. So essentially that's what they're tapping into, is they're getting all that good information and understanding what's happening on the grid. And then they're using that here in the building. And so at times of, you know, high peak, the building can kind of put power back into the grid, you know, from its battery system or from its solar system to help kind of reduce that dependency on fossil fuel plants. But it also can store and absorb some of that, whether, you know, whether it's being generated by its solar or again from the grid when it's kind of generating that clean energy. And so they'll store it in their battery system, and the vehicle charging stations apparently have a bit of capacity there for some storage as well. And so very cool building, very unique. I obviously feel this is kind of where we're going and heading to as far as kind of an electrified building. Like I said, unfortunately, I don't know if you guys do have questions on this particular project, I'll do my best to answer it. Like I said, I didn't work on it, but I do know a few people at Sonoma Clean Power. I'm actually hoping to get a tour of it soon because I'd love to hear and know more of the nitty-gritty details of how they got it working and how, you know, how it's been going and things like that. I'm also kind of hopeful that they might be hopefully doing some kind of case study or sharing some of this information with the outside world, because again, I'm sure this is kind of where we would all like to try to get to. So yeah, a very exciting project, one that actually is connected to the grid. So all right, I'm going to just pause here for a second and see if there's anything.
Yep, we have some more. Someone was wondering if you've got recommendations on, we were kind of talking about this earlier, getting the different systems to communicate with an energy management system. They suggest maybe standard language like BACnet or other specs that might be used to ensure that all the things, meters, building management, solar, can communicate with the EMS.
Yeah, I would say that part is getting a little bit easier, but definitely integration can be problematic. One of the things that I've been trying to work on and trying to get a lot of engineers to work on is to build a specification for energy management systems. There's not a lot of great ones out there, but ultimately that's where you probably, like, again, in a new construction, or even if you were kind of trying to define an energy management system in an existing building and you wanted to lay one over, having, like you said, that kind of information, specifications in there would be very important. The best one that I found, and again, I could send a link to it, is that one of the clients I work with is LBNL, Lawrence Berkeley National Lab, and they have actually kind of created, it's really the best one I've seen as far as a specification for energy management systems. And so some of it is addressing the items that you just mentioned, but it also is a good thing to kind of walk through, and it'll kind of prompt you with questions of things you should be thinking about when you're specifying or about ready to choose one. So I think it's actually a nice little kind of almost working document for you to help kind of identify what's important for you when you're trying to buy or purchase a energy management system. So again, I can share that with you. I'm not sure if that totally answered your question, but you're absolutely right as far as everything needing to communicate.
Excellent. And then a second question was, should all building management system info go into an energy management system, or should just a subset go in? Is there some sort of recommendation around that?
Yeah, absolutely. So bringing all the data into the energy management system is one, obviously very labor intense and probably not necessary. I'll give you an example, like a VFD. Let's say we have an air handler and that VFD. If you go and you look at the BACnet points list for that piece of equipment, and there could be, a dozen VFDs on your project, you'll find that they have 100 to 150 data points that you could pull. And so if this is something I get a little frustrated with, because engineers sometimes will be like, just bring them all in. But again, it can get kind of messy. And sometimes from the manufacturer, those points aren't even obvious what they are. You're kind of like, what is this? I don't know. So what I try to do is help identify, usually in the design phase, oh, we only need kW or kWh or amps, or some like key metrics that you want to pull in. And so, yeah, it's definitely, you also, if you're doing an energy management system as kind of a software service, they will actually charge you by how many points you bring in. So you want to bring in enough to do what you need to do, but you probably don't want to bring in all of them. And I do recognize that for some owners that, again, is kind of challenging, and they might need some help from a consultant or an engineer to kind of help identify those things. But there's plenty of clients out there that are very sophisticated and can do that on their own as well.
I guess that would be the importance of setting out those KPIs from the very beginning, determining what exactly you're looking to measure. Okay,
Exactly. Yep.
that is it for now.
Okay. All right. So we'll move into the next section, which, like I said, is one of my favorites here. We're starting with this project, which is a library in Half Moon Bay, California. It's a pretty small. It's about 25,000 square feet. And that's this is one of the reasons I like this particular example, is because a lot of times with energy management systems, you see them, examples of them with large buildings or campuses. And I'm not going to lie that some of those analytic tools are more powerful when you have multiple buildings in a campus style, but that doesn't mean that these small buildings don't need an energy management system either. And so that's where I'll kind of show you in this example of what we did. So this, I worked on this project as a commissioning agent. It is designed to be Z&E. There is somewhat complex. It's got a radiant in-slab heating system. It has no active cooling. I'll say it's pretty mild in Half Moon Bay. It's pretty close to the ocean. And what they do for cooling is they essentially kind of do a night flush, where they have automated windows. And so they'll look at the temperature outside as well as inside, make some determination if it should go into that mode. And then it would bring in outside air through a heat recovery ventilator to cool down the space for the next day. But this project got really complicated because there was a lot of integration. We integrated with the light system, the electrical meters, the automated windows, the automated shades, and even the ceiling fans. So definitely added some complexity there. But when I was done commissioning this project, I actually felt really great about it, because I felt it was really successful, because we didn't have a ton of issues, but we were able to resolve all of them by the end of commissioning. And then when I came back in the warranty period, there was really no complaints, no big issues, no complaints. So in my mind, when I left that project, it was working to the contract documents, it was working as it was designed, and it was good to go. But then the client reached out to me about 3 years after they occupied it, well, pretty recently here, about a little over a year ago, and they said, hey, Michele, we have not been able to achieve Z&E. We're not really sure why. We kind of expected we would. Can you come help us? Because we really want to get there. So of course I said yes. And where we started was, I was like, well, let's start with your energy management system. So a little bit of that backstory was, at the I would say it was the middle of construction, maybe even towards the end of construction, the owner decided to add this energy management system. And they decided to kind of build it as within the BMS. So the controls contractor did this. And I wasn't involved in that scope of work. So I'll be honest with you, at the time, I was just focusing on the commissioning and didn't really pay attention. But unfortunately, I don't think they identified like who was the audience. Was it meant to be a display for the public, or was it meant for the building engineers to track the Z&E? And so the controls contractor did the best he could. But when I got to the project, when we were going to try to start doing our monitoring period or measurement for Z&E, this is what I found. And so I'll ask you guys to take a look at that, and I'm going to just start to kind of point out some things, because I think you'll notice that there might be some things that are either wrong, missing, maybe not appropriate or very useful. So for example, if you start on the left, you'll see the main electric demand real time, and then as you move across, it's like kWh current day average and kW current day total with these little widgets. Now that's data, and I'm not saying it's bad, but it's, again, instantaneous data. I don't know if it's good, bad, if we're on track for Z&E at all. And so to me, it's not very useful. And then when you look below it, you'll see the same 3 widgets, but it says subpanel 1 and then subpanel 2. So they obviously submetered their electrical panel, but we have no idea if that's lighting, if that's plug loads, who knows? So it's not, again, not very helpful. And another point to make is I think there's like 7 or 8 panels, so we're clearly missing those. There's some water widgets there, and I think those were just meant for monitoring. And then of course the big chart there is their radiant floor, because I think they just wanted that there because they had never had a radiant system and wanted to kind of understand what it was doing. But again, not probably super helpful to them. And the one thing that you'll see that's not on here is their solar data, or the production kWh. So at the end of the day, in order to do this tracking period, we had to pull the data from the BMS and from the solar system, and Redcar, we kind of put it into a chart on our own using our own tools. But I'll show you how it ends up in the end as we go through this. So this is the chart that we showed, and I want to say that this started off, this wasn't just Michele or Redcar helping them achieve Z&E. We created a team and a process, and we met once a month to review the data. And what was really important to me was to establish a standardization of how we presented the data. And I actually learned that from LBNL, which is my next case study that I'll share with you in a minute. But I wanted so the team consisted of a couple of the building engineers and also the city mechanical engineer. So there's about 4 of us, and we would meet once a month to review the data. And so what you're looking at here is literally just whole building production and consumption. But what you might notice is that around each of those little boxes or bars is like an outline or a darker color. That is actually the target values. So we got the consumption targets from an energy model that was designed to predict real energy use. So that's maybe a key point. And then we also were able to get the predicted solar production data as well. And I'll tell you why it was so important to have, again, the targets there. So we actually tried to start this activity back in April. And what we did is we wanted to make sure before we started our 12-month rolling period that our data was good, that our meters were reading accurately, and there was no major issues. So we measured the solar, and what we found out, and we compared it to the predicted, and what we saw was it was about underproducing by about 25%, which is pretty significant. The good news was it was pretty easy to find out what the problem was. They had not cleaned the solar panels since they had moved in or occupied the building. So we cleaned the panels, and we measured the data again in May and found it to be about 5% of the predicted energy use. So we were good to go. And when we have these targets on here, we're not really looking for them to be super precise, but we're looking for, again, those gross anomalies, those things that kind of stick out like the 25%. So the other thing was, as far as kind of going back to targets, is we started in the month of June. So when we looked at just 1 month of data and we showed it to the team, they're like, oh, wow, we're doing great. Look at, we produced way more than we consumed. And I said, yep, that's good, but you can't really look at Z&E that way, right? Because it's over a 12-month rolling period. So it was really important for me to get them to understand how to really look at the data and compare it to the target, because obviously you guys know in the summer we're going to produce a lot more than we would in the winter. And as we move into the winter months, eventually we're going to flip-flop and we're probably going to consume more than we produce. So I used to use the analogy, we need to put money in the bank. We essentially need to overproduce, but we need to overproduce by a specific amount for when we again get to the winter months so that we can achieve that Z&E goal. So it was really kind of that process of understanding, what that meant. Were we really doing good in June? In this case, you can see we were right at our predicted target. So we were. And then this is the second chart that we would use on a monthly basis to show them. And so this is just our consumption, again, by month. And the different colors are all those different panels. We went, of course, and found out what they were, and we're able to figure out what's the lighting and so on. And so we know we needed to do something because this building hadn't achieved Z&E. And so we were going to need to implement some energy efficiency strategies. So again, looking at that first month of data, the two blues at the bottom, the light aqua is the HVAC and the dark blue is the lighting. We decided to focus on those two areas. And so again, this was very much a team effort. The building engineers was very involved with identifying the energy efficiency measures and helping do the actual implementation as well. So on the HVAC side, a couple of the changes we made in the building was we identified that the radiant system, first of all, it has the slab has a set point, and it was set to be 79 degrees all the time, or maybe it was even 80, which is maybe appropriate in the winter months, but not appropriate in the summer months, and actually could lead to some comfort issues. So we obviously changed that, and we implemented a seasonal shift on the set points that was kind of automatic within their control system, but it also gave the operator the ability to kind of tweak that a little bit too if necessary. But we adjusted that, and then we also discovered that the that night flush that I was talking about, well, one time I guess it went into that mode, and there was like a big meeting that early in the morning, and everybody was cold. So somebody turned it off, and essentially what happened was those HRVs then were on 24/7. And so obviously that was a little bit of low-hanging fruit. So we fixed that, but we also, again, kind of changed their programming so they had more ability to kind of maybe take it out of that mode, or if they knew a meeting was coming, maybe we don't want to get it that cold, or we can change the set point to only keep the windows open until it achieves this set point instead of that one. So it gave them a lot more flexibility for the future. But the key was that we did create a reduction in energy, and it was visible from the charts. And so when they implemented it and we came back and looked at this data, they could say, oh yeah, we did make an impact. Look at there, it was positive. Similarly, on the lighting system, we made a change around the August timeframe. In this case, what we discovered was, well, first of all, with it being a library, there was a lot of lighting in it. There was actually quite a bit of it that was what I would call cosmetic. It wasn't meant for reading or doing tasks. So we worked with the librarian because we discovered that that lighting was most of it was at like 100% output. So we went and we tweaked it, made sure there was no issues. We don't want to affect functionality, but we walked through that and kind of made those changes. We also discovered that some of the zones were not properly kind of mapped for daylight dimming either. So we had to make some changes to the daylight dimming, but ultimately we're able to see a reduction as well. So the one thing that you will notice here is I don't have 12 months of data on here, but we have completed the 12-month cycle, and they did achieve Z&E by a decent amount. So it was a great accomplishment, and they were all very happy. But to me, even though that's a great thing to feel proud about, I was actually more proud about the fact that they now knew how to do this and how to track their building, and hopefully can maintain it and, again, have persistent energy performance year over year, not just this one-time 12-month period. But in order to do that, they needed the tools, right? So kind of going back to that energy dashboard. So the last piece of the pie was for them to get a project together so that they could go back and update their dashboard and create some visualizations and charts, probably very similar to this. Unfortunately, it is not quite done. It is still in process, but that's kind of what's happening there. And so I have high hopes that we'll get something that is very useful and helpful for them to, again, be able to continue this in the future. Okay. All right, so now I'm going to move on to LBNL. So this is in Berkeley, California. It is a large campus, and I would consider this client to be a very sophisticated client. A lot of smart people, a team of facilities, energy engineers, sustainability teams. So they have a lot of resources, okay? probably not your typical client, but I think it's worth giving you this case study because I consider them to be kind of best in class when it comes to ongoing or monitoring-based commissioning. And so I wanted to share this with you. Now, on this particular project, what you're looking here is actually a building called the IGB, the Integrative Genomics Building. And it is a lab. It's 2 floors of labs and 2 floors of office space. It's about 90,000 square feet. And it's a very, very complex building. It has in-slab radiant heating and cooling. It has chilled beams. It has heat recovery on both the air and water side. And it also has a chilled water plant that has like 3 different modes, and heat pumps on water source heat pumps and air source heat pumps. And of course, we integrated into just about everything again, as far as lighting, shades, meters, and so on. So pretty complex. But what this client did that I've never seen done before is that they identified their KPIs very, very early in the project, and they were very involved. I mean, they essentially established them. And what they did is they gave these KPIs to the engineer of record, and they put them on the contract drawings. So that's what you're looking at here. This table, which I know is probably hard to read, but this table is a snapshot of those metrics. There actually is about 34 of them that they identified that they wanted to measure and monitor to verify their performance. And I should note that this was not a Z&E project, but it is an all-electric project, and it is considered pretty high performance for a lab. But these metrics, like I said, played a great role, and this chart was so helpful. It basically is giving you the metric, and it'll tell you a lot of great information, from the units of metrics to what is your target, or what's your range again, and then what are the raw data points we need to do the calculation if there was a calc. And then of course it actually gave the calculation, and then there's a little bit more to the chart that got cut off, but ultimately where's the data going, because they do have quite a few different systems on their campus. And then also kind of who was responsible, like division 22, 23, or 26, or whatever. And so this became really important because it was the first project where I was able to start with these metrics at the very, very early of the project, follow it through the design phase, the construction phase, and into the occupancy phase. And it was really a guide. We used it all the time to make sure things didn't get VE'd out, make sure that we had good data and all the things necessary in order to actually perform these calculations or metrics at the end of the day. When we got to the end of the project, their intent was that they have this ongoing commissioning team, which I'm going to talk about in just a sec, but ultimately their goal was to put all of these metrics into what they use, which was SkySpark. Unfortunately, there was some other projects going on at the time, so it got delayed. The SkySpark integration got delayed for about 6 months. So they asked us to stick around with the project and do a little bit more of an expanded, more than your typical commissioning role. And basically they wanted us to measure all of these metrics for them for the first year of occupancy to see where they were at and how they were doing. And so those are the charts. Those are just a couple of the handful of charts at the bottom that you're seeing, is us pulling that data from the BMS, using some of our tools to kind of verify those metrics. The good thing is most of the metrics they were meeting. And you can see the chart on the right, and the last one is the EUI of the building. So again, the design was 109 and they actually achieved 105. So they were able to make that, which is obviously, again, a positive thing. What I guess I wanted to say though is that, obviously a lot goes into a building in order for it to be able to meet its EUI or performance metrics. I wouldn't put all the credit on this, but I would argue that it was really helpful, and definitely consider it best practice. I personally would love to see the metrics kind of put on design documents on every project moving forward if possible. So again, I think it's definitely a great way to go about it. So let's talk a little bit about their team. So they have a staff of about 7 or 8 people. Now, not everyone on this team is full-time, although some of them are. And I would say it's a cross-functional team. They have, some engineers, sustainability members, and then also some building facility engineers and a programmer. Now, the facility engineers are full-time on the project, and they do not do like hot or cold calls. They are dedicated to this ongoing commissioning team. And so what this team does is they meet regularly, but this process or this cycle that you're looking at on this graph is a 30-day cycle. And they kind of meet to select those energy efficiency measures. Then they go out and they work on them, and they kind of document the progress, the results, do the verification, and hopefully calculate the savings, and then continue that cycle. And so while I stuck around that first year, I got to interact with these guys a lot, and I found that I learned a lot from them, and I'm going to share that with you in a second. But the point here is that even when we have energy management systems that are automated and hopefully identify things for us, there still is a human element that we can't get away from. When it identifies that maybe there's a leaky damper or a leaky valve, somebody still has to go out in the field and fix it. We haven't got to the point where that human element is completely gone. As well as, like you said, if there's multiple energy efficiency measures, trying to identify which ones make the most sense usually requires a team to kind of review them and to make that decision of where they want to spend their money and their time. So again, this is a sophisticated client that has a lot of different softwares and analytic softwares and energy management systems and all these things, but they still recognize that a process still has to be there in order to be really successful. Now, two of the things that they kind of attribute to their success is standardization and visualization. And so they are very big fans of heat maps. And so what they do on their campus, and most of their buildings on their campus are air handlers with VAV boxes. So they have created a heat map for all their buildings, and they basically try to put all the VAV boxes on a heat map. And part of this is because, again, the standardization. So every building kind of looks the same and giving you this high level data. And then when they have the facilities engineers, they're able to, as part of their job, they're seeing the same thing over and over again. By having that standardization, they really learn how to read it, when to take action, and so on. And then by using the visualization, hopefully that's making it easy for them or easier for them. And so those are the two things that they stress to me over and over again. Of course, in maintenance department, you might have high turnover. So that was important too, is it was easy to kind of train and easy for them to kind of maintain. So on that building that I just talked about, the IGB, now there were a few VAV boxes, but predominantly the system was a radiant heating and cooling. So we essentially had to customize and make, and this is where customization came into play, is we made a heat map that was similar to what they had been using at all their other buildings, but we used it with all the hot water valves and all the chilled water valves that were on the radiant system, similarly to the VAVs. And there is one more thing I want to point out that they do that's quite amazing, is that kind of going back to this process, is when they find an energy efficiency measure that works, and they don't do this for all, but I would say ones that have a significant cost impact, is they will say, okay, this is a good one. We want to make sure that it is persistent. So we will come back and we'll have our programmer create a custom visualization so that we can verify it on a regular basis. So that programmer will come in, it doesn't have to be a heat map. It could be some other chart or visualization, but a way to easily kind of verify the energy efficiency measure. And then it becomes part of somebody's kind of job or process to check in on it, on a fairly regular basis. And so that is considered, they call that persistent energy savings. And it's really important to note that, because I think we all know that if you implement an energy efficiency measure, you could come back 6 months from now and it might be gone, or it might not be saving energy anymore for a lot of reasons. I mean, somebody could override something, turn it off, change something. And so it's really important for them that they're able to maintain it. And if you go to their website, when they report energy saving dollars, they have a category that's called persistent energy savings. And so to me, this again is them really understanding that it's not a one-time thing, that we want to be able to maintain this over and over again. And yeah, so that was a great experience working with them. I recognize that they're not probably, again, the typical client, but I think it's worth kind of understanding how, again, some of the best practices are being done out there in the industry. Okay, the next one here is Genentech. So I, again, worked as a commissioning agent on this project. It is that glass building that's kind of sandwiched between the other two. It's an office building, and I was doing the commissioning on it, and it has a little bit of the same story as um, that Half Moon Bay, that they decided to implement an energy management system late in the process. It wasn't quite in construction, but I would say very late design, almost early construction. And it was coming from the engineering group. They had some additional funding and they wanted to run a pilot project, and they decided that they not only wanted an energy dashboard, they wanted to build it from scratch. So I was kind of like, what does that mean? And why are we doing this? So I did ask them, and they're like, there was two reasons. Because again, this is a client that has a large campus. They already had multiple different systems and analytics softwares they were using. So I was like, why are we doing this? And they said, well, we don't like any of our energy management systems, so we want to make one that, is exactly the way we want it. I said, okay. And then they also wanted to, one of their goals was to achieve that multiple people would be using it. So the energy team or sustainability team, the engineers, as well as the building facility engineers. So again, we have three different audiences that are really looking for three different potentially pieces of data or tools or functionality. And then what they mean by from scratch is we literally, they use a software platform called Tableau, and that's where you can create these visualizations, but ultimately it was built from scratch from a programmer who had no HVAC experience and no energy experience. So literally had to be told how to do everything. Now I was just a team member because this was a really intense process, I'll be honest with you, because there's a lot that goes into making an energy dashboard, things that I hadn't even thought of before. And of course, there's a lot of IT and security issues around that, which I'm not an expert in, but we had to obviously pull somebody in to help us with those types of decisions and things. And bottom line is, I think we started from the right place. What you're looking at here, and again, recognize it's hard to understand, but it was really just a way for us to kind of organize what are the meters we have on the project, what are the things that each of the different groups that we described want to look at or measure. And so this was just kind of the start of it. We ultimately landed up doing something a lot more detailed, kind of like that LBNL, where we had to literally spell out, these are our metrics, these are the data points we need to pull in, this is the equation we want to do. We had to make sure they had the right conversion factors, the right units of measurements, all that kind of stuff. And then we even had to tell them exactly how we wanted the data displayed. We use kind of what's called wire diagrams, which was essentially like sketches, or maybe using fake data to show, hey, we want this to be in a pie chart, or we want this data to be in a bar chart. But we literally had to go to that detail. So what I can tell you is that it took us probably 3 times as long as we thought, and probably twice as much money as they anticipated. But we did make a working dashboard. And so let me go ahead and show that to you. This is just 2 of the screenshots. There's about 7 pages to this dashboard. And we got it working, I would say 95%. There are a few things that we couldn't quite get working right, but for the most part, it was accurate and working. And so again, it was not bad, and not bad looking either. And so throughout this process, as I mentioned, the engineering group was kind of leading this effort. So the sustainability team and the facilities team would sometimes pop in, but they weren't kind of regularly involved. So at the end of it, we kind of shared this with them, asked them to kind of not only review it, but to use it, look at it, play with it. And then we were going to have a meeting to kind of get some feedback. So when we had that meeting, it was maybe a little surprising, but basically they came back and they said, yeah, this is great, but we're not going to use it. Like, why not? Why not? And so basically their response was, this is not data that I need in my daily job. This is not tools that is helpful to me, and so on. And with a little self-reflection, the engineers were like, you know what, this is data that we wanted. I guess we made a dashboard for ourselves, or an energy management for ourselves. Needless to say, this, I think they maybe had high hopes that if it was really successful, that they would push it out across the campus, or at least to new construction projects. Like I said, needless to say, it did not happen, and probably is considered a pretty expensive learning lesson. But what they did take away from it is, by going through all the steps that we needed to go through to make this thing work, they really were able to identify which things they liked, what they didn't like, and create that specification or that design document of what they want in an EMS system, you know, the tools, the functionality, and so on, the way they want the data displayed. And so they kind of did create this kind of, like I said, design narrative or specification for the future. So it wasn't like nothing came out of it. And I guess I will share one other thing on this particular project that was considered highly successful. And this is going back to that automated fault detection diagnostics. So I'm showing the same one I showed earlier, but ultimately we created some very customized ones for this building because the first floor had a radiant heating slab, and this was kind of new to them. And they wanted to know, not necessarily when it failed, but if it was just operating efficiently, and what are the, you know, some of the things we should be verifying on a radiant system. So we helped them create automatic fault detection diagnostics for a radiant floor, and created, I don't know, I'm going to say 5 or 6 of these custom fault detection diagnostics for them, which they were very happy with. And they landed up creating more of them for the entire building, even on all the other systems. And the reason for it is maybe a little different than what you think. So this is a campus, and the way that they were kind of doing their maintenance was basically when an alarm came through the BMS, it would go to another system, and then it ended up kind of going through 3 different systems before it would get to the facilities personnel. And so a lot of times the right information wasn't coming through to them, and they would go out to kind of troubleshoot it. And it could be any trade. It could have been an electrician, or it could have been an HVAC tech. And so a lot of times it was the wrong technician. And so they would have to come back and get the right technician. Then they would go out and troubleshoot some more, and they might not have the right tools in order to fix the issue or even troubleshoot the issue. So it was very inefficient how they were kind of going about troubleshooting issues. And so when we implemented this one for this project, we made sure that when it came through to the facilities people, that it had all of that additional information, like the recommended action and the possible diagnostics. So they started getting a lot more information. And so that way they knew exactly who to send out. Oh, I need an HVAC guy. Oh, I'm going to need a ladder and a X, Y, and Z. And so their process became much more efficient. And you know, one might argue, well, that's not an energy efficiency measure, but I would argue it is, because maintaining a building plays an important role in building performance. So to me, this was you know, one of the successes on this project. All right. Now, the last case study is, I'm going to go back to this UC Davis, and I know I've kind of already talked about it. On this particular project, we interacted with this client. We did not do commissioning. One of the other things we do for our company is we do a lot of research and analysis on existing buildings, and we take a lot of the real building data and analyze it to see if the energy efficiency measures are working, and potentially how much, you know, energy they're saving. And this research helps to kind of, for future code, energy efficiency measures as well. So we got to know their energy team and their sustainability team, and that's how I kind of came across this dashboard. Now, this is an example where they did build this literally from scratch as well. So this is similar to Genentech, but they did this. They will not share with me how long it took them to do this. So I'm not really sure, but they swear to me that even a lot of the visualizations were done by students who, you know, maybe were in computer science, or, you know, it wasn't all done by HVAC, but it was done within their campus with their staff members. And so they did describe it as kind of an iterative process, where they would, you know, do a little bit and then have the energy or sustainability team use it and see if it was effective and work, and then they would go make tweaks. And so I envision it took them a little bit of time to do this, but ultimately I think it's an amazing, like I said, energy dashboard. So again, I encourage you to check it out. But I wanted to show you just a few other features on this system. As I mentioned, you're able to kind of drive down into the building level. And so at some point you get to the building level, and the chart on the left, which is showing chilled water. I'm trying to remember. I think one of them is steam, and I forgot, maybe one is actually electricity, but it's basically trying to show you the different sources that are going into the building. And you know, what you're looking at is an interval data, you know, the trend over time. But when you go to this website, you'll find, if you scroll down a little bit, you'll see some of this information that's shown on the right. So it is telling you how to read the data. So it basically is saying, okay, so let's take that chilled water, right? And The other line that you're witnessing on that graph is the outside air temperature. So of course, when it's cold outside, we expect that the cooling loads are less, or should be less, in the building, and therefore we should see that chilled water load drop. If we don't, and we see a chart more like the one on the right, that's indicating a problem. And so then it'll kind of go a little bit further as, okay, here's some recommended actions, kind of back to like that whole fault detection. Here's some things to maybe investigate. And so again, I think this is an important thing, you know, in a dashboard, is to not only identify issues, but you know, again, possible diagnostics or maybe where to start. That makes it even that more effective. And then the last thing I'll say is that they have a lot of great little charts on how they're kind of tracking energy savings by, you know, again, electricity, steam, chilled water, by building, and so on. So there's a lot of great things within this energy management system. But again, kind of iterating that LBNL is that they do also, again, have a process very similar to LBNLs, where they are constantly kind of figuring out what they want to work on, and recognizing that, again, there's a human element to it. It's not just the actual software itself. All right, so that kind of wraps up my case studies, and we're kind of here now at the end of the presentation. I hope I've shared with you, you know, some, like I said, some real world examples of kind of what's going on out there, and also how to be more effective with your energy management system, or some of the, you know, important things that you need to have in consideration to make them work to the best of your ability for that specific client. So I will go ahead and see if anybody has any questions, and also let Katie maybe go over these last couple slides.
That was great, Michelle. I really appreciate seeing case studies on how these things work in real life. Um, and oh, Cameron found a document at LBNL that I'm gonna copy and paste into the chat for everybody. And maybe Michelle, this was what you had found. Um, if anybody's interested in looking at some of the work that LBNL has done on this. And to get back to my slide, this is a slide talking about some of the increased incentives that I mentioned earlier, that we have a presentation on next week with some of our staff here in City Light. And all of those are links that you can click on when you get the presentation after today. And that is all that we have today. Couple more seconds. If anybody has any questions, go ahead and type them in the chat. Michelle, thank you for coming back and telling us how this can work with electrification. That's an important thing that's happening around the country, but in Seattle too, especially. And I think a lot of the folks on the call have been finding the broadening our focus to electrification useful. And as we end today, reminder, there's a little survey to take. I think it's 10 questions. Tell us if you found this helpful, what you'd find useful beyond this information. Just let us know how we're doing. Thank you, and have a great day, everyone.
Thank you.